So just addressing the vocabulary at the beginning of this right now, lesson 3.2, relations and functions. A relation is a set of ordered pairs. Would you just circle that, because that's kind of small, and I want you to make sure that you understand. When I say the word relation, you can visualize that we have a set of ordered pairs, some points that we could put on a graph. So any set of ordered pairs is considered a relation. The relation can be given in the form of a table, a graph, or a mapping diagram. In other words, we can take these ordered pairs and we can rewrite them in a table, we can put them in a mapping diagram, or we can graph them. Okay? That's what we'll practice tomorrow. Today what we're going to deal with is the other definitions that are here, domain and range. So I want you to put a box around domain. The domain is all the x values. So from that relation, we're going to pick out all the x values, and they are going to become what is considered a set of, known as the domain. And the range, you can put another box around that one, the range is all of y values. So sometimes a nice way to help remember these is by using alphabetizing. Domain goes with the x values, range goes with the y values. D comes before R in the alphabet, X comes before Y in the alphabet. So domain, X, range, Y. Okay, so and it's going to be really important that you right away kind of get that in your head. When she asks for the domain, or the problem asks me to give the domain, what am I supposed to be looking for? I'm supposed to be looking for the x values. Okay, we're going to write the domain and the range in set notation, it's called. Okay, so let's start with the domain. We can just call it capital D, and we're going to put a colon behind that. We're supposed to find the domain and range of this relation. It is written in table form. How many ordered pairs are there really there? Because remember, a relation is a set of ordered pairs. How many are there, JC? There are 4 of them. There's an x value and below it is a given y value. That makes an ordered pair. So we have 4 ordered pairs, but when we write the domain and the range, we only have to list the x values or the y values, and we don't have to do it. We don't have to do any repeating. Well, let's look at all the x values. Our x values are -2, -1, 0, and 1. Are there any repeats there? Are there any repeats there? No. So, okay, here you want to learn how to make those fancy brackets there. It's like a little parenthesis with a V sitting on its side with another little parenthesis below that.
Those are like weird things.
Yeah, it's called set notation. So we're going to start with -2. And what we're going to do is we're always going to list them from smallest to largest. So they happen to be from smallest to largest right now in the table, so we can just copy them down as they are in the table. And then we make another closing fancy bracket at the end of our set. So there's our domain. Remember, the domain is made up of the x values. Now, let's do the range. The range is the what again? The y values. Okay. Are there any repeats in the y values?
Yes.
Yeah, 4 is in there twice, isn't it? And remember, we're going to go from smallest to largest. So we only have to list that 4 one time, and we're going to start with the smallest y value and go to the largest. So what's going to be our first member of our range set? What do you think is going to be our first member in our range?
0.
0. Okay, so make your fancy bracket. 0, comma. What's the next one going to be? What's the next member of our range? 1. And what's the next member of our range?
4.
4. Do we have to write that 4 again? No, we're not going to do any repeating in these sets. So, the x values, there happen to be 4 different ones, so that's why there's 4 of them in the set. And in the range, even though there are 4 y values, there's a repeat. So we say, you know what, we don't need to do a repeat. So we end up with 3 members actually in the set. Okay. How about number 2? do you think here? What do you think we would, so capital D stands for domain. Start with our fancy bracket. Anybody want to take a chance of telling us what they think the domain of that relation is? Trey?
Would the domain be the first number in each?
Okay, remember remember the domain is made up of the what? X values, and are the X values the first number in the ordered pair?
No.
They are, aren't they? Yeah. Ordered pairs are made up of, they have an X, comma, Y. So that is an ordered pair. The first value is an X. So remember, we're going to go from smallest to largest. So how would our domain be then, Trey, do you think?
-2 or -2, -5.
Isn't -5 smaller than?
-5, -2.
-5 is the smallest. -2 is the next smallest, and the last one is 4. Okay. Now the range. The range comes from the Y values, right? Okay, so what, anybody want to tell us how they think we could write the range? Dakota?
We use fancy bracket. 5, 6, 12. Fancy bracket.
Okay, 5, 6, 12, the Y values. Okay. Questions so far? Okay, how about you try number 3 on your own? Try it. You're working with pencil. If we have to erase, we will. Try number 3 on your own. I want you to write what you think the set would be for the domain, and what do you think the set would be for the range? Remember, smallest to largest, or in other words, moving from left to right on the number line. Okay, someone who hasn't offered up their answer already another time, another one of these. Someone who has not put their hand up to give me the domain. Emerson.
0 to, 1, 2, 3, and the bracket.
Okay, there's our domain. Oh, and were some of you like confused? You're like, well, there's no way, nothing tells me what are the X's and what are the Y's, did it? So you kind of think of it like this is like how we write the ordered pairs. The X comes first and the Y comes second. So did anybody look up above to get an idea of how to do these? Remember I said there's examples above? So the first oval is representing all the X's and the second oval is representing all the Y's. So what is our range? Good for a new hand, Isaac.
5, 6, 7, 8.
5, 6, 7, 8 in numerical order. Okay. Okay, so anybody get questions about that one? Okay. Together, class, let's get your capital D and your colon and your fancy bracket, and then together we're going to say, okay, here's our domain. And we're going to remember that we're moving across the number line from left to right as we're stating these. So everybody got their capital D, their colon, and their fancy bracket to start us out? Okay, together as a class, what's our first member of this domain?
-3.
-5. Next one.
-4.
-4. Next one.
-3.
-3. Close our set. Range. Get your capital R, your colon, and your fancy bracket. And notice mine are getting kind of sloppy, but just make sure they don't look like a parenthesis, okay? They're not really just a parenthesis. They are a curly bracket. Okay, class together, what's going to be the first member of our range? 10, okay. That's right and top. 10, 11, 12, 13. Okay. Okay, so again, the first oval always represents the x's, the second oval will represent your y's. Trey.
Do the arrows have to be equal?
Okay. How many ordered pairs do you think this relation has? What do you guys think? How many ordered pairs do you think that relation has in number 4? Trey has a really good question here. How many ordered pairs are there? 4? 3? Probably either 3 or 4, right? Okay. Well, look what it says. When x is negative 3, y is 10. When x is negative 4, y is 11
Or 12.
or 12. So there's 2 ordered pairs right there. That's 2 ordered pairs, 2 separate points. And then when x is negative 5, y is 13. So in reality, there are 4 ordered pairs here. So when you ask the question, what was your question again? Will you just restate it for me?
What did the arrows mean?
What did the arrows mean? Okay, instead of writing, just like how we didn't write up in these, this one up here, we didn't write the 4 more than once. Okay, when we didn't write the 4 more than once, that's kind of what they're doing here. They're saying, you know what, here's an efficient way to write it by just putting an arrow going to the 2 different y values that x value has. So you will not see repeats in mapping diagrams. Okay, you'll see arrows taking care of that for us. Okay, the tricky ones are number 5 and number 6. Okay, in number 5 and number 6, can you tell me something about those graphs? Can you tell me how many ordered pairs the relation has in number 5? 4?
2.
2.
None.
None? Well, if you don't have any points, how do you get a line segment?
0.
1,
In fact, you have to have at least how many points to get a line segment?
1,
2.
2, 2.
Well, there's going to be one at each end, a start and a stop. How many points do you think there are in between those 2 endpoints?
And then one line is.
How many? Depends on how long the line is.
The line segment is.
Can x be equal to 1 and 9/10?
No.
Can x be equal to 2 1/2?
No.
Why not? Was there ever somewhere that said in ordered pairs you always have to have whole numbers
Yes.
or integers? You can have fractions. You can have decimals. You can. So
1/2.
here's the deal, you guys. There's actually an infinite number of points on that line segment. We can't even name all of them in that relation. So we're not going to be able to name them all in our domain or our range either. We're going to have to use a compound inequality or maybe a simple inequality, depending on the graph, to do it. So let's do this. Let's put the points at the end of this line. Let's identify what their names are. So what's the ordered pair name of the bottom end of that line segment?
-2, 1.
-2, 1. Would you write that right on your graph like that? Write the ordered pair name. What's the ordered pair name of the other endpoint?
2, 4.
2, 4. So here's the deal. The x values are never going to get smaller than -2 because it doesn't keep going that way. And the x values are never going to get larger than what? +2. Yeah. So here's how we write the domain then. We say the domain, we still do our set notation like this. The domain will be between -2 and +2, and it's going to include those guys. That's how we write it. We write it as a compound inequality. All those points on that line segment start at -2, they end at +2, and they can be anywhere in between. Okay, anybody think they know how we could probably write the range then? What do you think we could do with the range? Remember the range is the what values?
Y.
The y values. How can we write the range? What's the lowest y value? 1? Right here, 1. Lowest y value is 1. What's the highest y value? 4. These are y's, not x's. So we write a compound and an equality. Y has to be somewhere between 1 and 4, including 1 and 4. So up and down, it doesn't go any lower than 1, it doesn't go any higher than 1, or 4, excuse me, on this line segment. Okay, anybody has some uncleared up concerns about that one before we try another one like that? Okay, here's what we're gonna do. Every time we have a like it's kind of continuous here, isn't it? We're gonna name the corners or the endpoints. Well, here it's corners, right? There are some endpoints and then it turns into this. So what are the ordered pair names at each of those corners is what we're gonna do. So go ahead, name those 4 ordered pairs on your graph. Name those 4 ordered pairs. Okay, so how do you feel about your order pairs names versus mine? Are we in agreement? Okay, so now we start with the domain. Domain x's. So we go like this for domain. Think this way, x's. Goes from year to year. What are those year to years? -3 to I think I did this one. Nope, not to +3. What's the x value? X value is 2, so we're going out to 2. So here's our x is between. It goes no further than -3 on the left. It goes no further than +2 on the right. Back and forth for x values. Okay, and now we'll do the range. Try the range on your own. See if you can get it. Try the range on your own. Remember, our range is up and down. Y values. What's the lowest it goes? What's the highest it goes? Compare with a neighbor. You're at a table alone, find somebody that else that's at a table alone and compare with them. Okay, who wants to offer what they believe the range is? Dakota.
Range is 1 or y is greater than or equal to 1. Or y is less than or equal to 3.
Okay. How many of you agree with Dakota? That's the range. Hands up. You agree with Dakota?
I agree with this.
Yeah, that's the right range. It doesn't go any lower than 1. Doesn't go any higher than 3, and it can be anywhere in between besides. Okay. Okay, the plans were, we were going to go to the back side and we were going to start talking about this, but I'm revising those plans, okay? So, anybody have questions though about domain and range? That's all we're going to cover today. It's dealing with, okay, what's a relation? So remind me, and yourself. What's a relation? A set of ordered pairs. How can they be written? They can be written as ordered pairs. They can be in a table. They can be on a graph. those are called mapping diagrams, yeah. So we're going to be able to look at them in all of those formats. Okay,